Today we're going to try and take a look at everything we've learned about factoring and to try and put it all together into one big review. So when you're doing the homework for factoring, you notice it's not that difficult if you just remember the steps. But each kind of factoring kind of looks like its own thing. And so not only do we want to be able to learn how to do it, but we also want to be good enough and comfortable enough with each individual kind that if they should pop up randomly later as a smaller part of some larger question, that we can recognize them for what they are and we can do them, because it's not always so easy as saying, here is the factoring chapter, here is the section on difference of squares, now go do these questions. If it tells you in advance it's difference of squares, well, it's really basically given everything away. And so what I've done is I put together just a bunch of factoring questions and I mixed them all up out of order. And what I would suggest is if you grab a pencil and a piece of paper and try it along, and before I get to the answer of each question, just pause the video and see if you can do each one on your own. Now, just to review, you already know several different kinds of factoring. So the first one is common factoring. That is the one where you wind up with something with a bracket, make that a little bit nicer, and you have little bits and pieces inside. Those are supposed to be squiggles. The second kind is when you have the trinomials. So this is something that is x squared plus something x plus something, and that turns into two brackets like that. The hard version, where you put a letter in front, ax squared plus something x plus something, and that still turns into two brackets, but it's more work. There is difference of squares, where you have something squared minus something squared, and that turns into two brackets, where one of them is plus and one of them is minus. Perfect square trinomials, which will turn into something plus something squared, and grouping, which is, well, grouping is grouping. So we're going to take each question one at a time. As I said, if you want to try them and stay ahead, just pause the video and work on them, but just to see the process of not only how do I do each of the individual methods, but also how I pick to decide which method is the right one. And this video is going to go on for a long time, so do as much as you want. Pause, come back to it later. It's okay. Now, the rule is always the same, which is I want to try and do these steps in order. So I always ask, can I do the easiest kind? And if I can't do the easiest kind, can I do the next easiest kind? And if that works, great. If not, can I do the next easiest kind? And so on and so on and so on and so on. So, to the questions. Oops. There we go. So let's see. Noticing all of these, there are three things, and each one has an x. So I can pull out an x. So common factoring, 3x squared plus, no, I'm sorry, that is, that's not squared. Go away. That one will be squared. Minus 2. Now notice this is written out of order, and that sometimes happens. Maybe if it's as part of a larger question. So the next thing is, just to make my own life easier, what would this look like if it was in the order that I'm used to? Okay, now this looks like it could be that hard kind of factoring. So I take a look at the first number and the last number. That is 4 times 2 is 8. I make the complete list of all the ways to make 8 by multiplication. 1 times 8, 2 times 4. I look for a combination that will make minus 3. Nope. All right, so this is done, but I'm not going to say does not factor, or DNF for short, because even though this is not factorable, I was able to do some factoring. So I did do some factoring, and that counts as an answer. It's not does not factor, it just doesn't factor as much as we'd like it to. So that's done there. 9c squared, okay. 9 and 9 and 24 are both divisible by 3, but 16 is not. Okay, so common factoring doesn't work. 16 times 9. And this is where you want to have a calculator handy. So 16 times 9 is 144. And so I make the complete list of ways to make this by multiplication. 1 times 144, 2 times 72, 3 times 48, 4 times 36, 5 will not work, 6 will work. 144 divided by 6, 24. 7 will not work. 8 will probably work. 8 times 18. 9. Of course, 9 times 16. 10, 11, 12, 12. Okay. Now, of course, I've been silly. If I was paying attention, 9 is 3 times 3, and 16 is 4 times 4. And whenever, so I should look at what is 2 times 3 times 4. That is 2 times 12, which is 24, which is exactly that. So I could have skipped all that if I was paying attention. And I can just write this answer right away. This would be 3c. This would be 4. This would be plus squared. Okay, let's say you didn't notice that. You could still go back to this list and realize that if I wanted to make 24, I could use 12 and 12. So this could do the same old method, 9c squared plus 12c plus 12c plus 16. Divide in 2. Okay. On the left-hand side, both of these are divisible by 3 and c. 3c plus 4. And on this, both of them are divisible by 4. 3c plus 4. Pull out the 3c plus 4. That's these two. And I'm left with 3c plus 4, which is 3c plus 4 squared. So whether you do it the short way or the long way, you get the same answer, and I will not reshoot this and just to admit to being embarrassed that I didn't notice I didn't notice these perfect squares sooner. Oh well. Let's see. Z squared minus 7z minus 18, nothing in common, so I will try the trinomial method. Look at the number 18. 1 times 18, 2 times 9, 3 times 6. I want to make -7, so I can do 2 and 9. That will be plus 2 and minus 9. That just means I can write the answers, 2 brackets, 1z there, 1z there, plus 2 there, minus 9 there, done. Easy. So I'm on the lookout for squares because the last one got me before. So m squared is equal to m times m, and 49 is equal to 7 times 7. So the answer factored is just rearranging those 4 pieces. 1m here, 1m here, 1 7 here, 1 7 here. One of them is a plus, one of them is a minus. That was easy. Okay, both of them right away, 4 and 24. Both of those are divisible by 4, and both of them divisible by k. Bracket. So this leaves k, and 24 divided by 4 is 6. Okay, so that's fine the way it is. And this one, it started out looking like it might have been a difference of squares because this was 4 and k squared, but the other one turned out not to be. So it looked like one thing, it turned out to be something else. That's fine. Oh, okay. 18x to the 4 minus 9x cubed plus 24x squared minus 12x. Could I pull something out? Yes. 3 of these are even, but 9 is not. Okay. All of them divide by 3. And all of them have an x. Okay, so far so good. So 6, take it cubed, minus 3x squared plus 8x minus 4. Okay, this has nothing left in common because I'm going to take a shot that this can be done by grouping. Grouping, remember, is maybe a good idea when you have 4 terms, but also when you look like you might be able, when you look like you might be able to factor by grouping. So bunches of these are divisible by 3, bunches of these are divisible by 4, lots of x's floating around. This is a good candidate for grouping. So I split down the middle. Let's get the right color going on. So both of these are divisible, both of these are divisible by 3x. So 3x squared, x minus 1, and both of these are divisible by 4. Oh, yep, this is working. Okay, and remember I did factoring previously, so this is all inside of a bracket with 3x in front of it. So 3x, and now I pull out this, and I'm left with squared plus 4. And then I ask myself, are these brackets necessary? Or can I not write them and still have the same answer? So this is just multiplication. This is something times something times something. And whether I put these in brackets, so I do these two somethings multiplied together and then this something, it's the same as others. So I can just write this without all the brackets. Um, 2x minus 1. And the last thing I might do is I might pause to ask myself, this is the most complicated of the ones that are left, and nope, nothing can be done there. So if that 3, this is not part of the question, but you can sort of think to yourself, if that 3 was not there, this would be x squared plus 4. Yeah, no, it still wouldn't factor. So no, we're good, we're good. All of this is done the way it is. Let's keep going. Okay, probably a trinomial. It has the letter in front. 4, 5, and 12. No, nothing I can pull out, so that's fine. I look at the 4 and the 12. 4 times 12 is 48. So I look for ways to make 48 by multiplication. 1 times 48. 2 times 12, 3 times something, 16. 4 times 12, 6 times 8, 7, no, 8, but I've already written 8, so I'm done. And I want to find a pair that adds together to give me 5. 1 and 48, no. 2 and 12, no. 3 and 16, no. 4 and 12, no. 6 and 8, no. Okay, so if I have made this list correctly and everything doesn't work, that is the point where I am allowed to say DNF for does not factor. I was wondering if there's going to be one of those in this. Okay, so let's see. Common, definitely things that I can pull out. So definitely 4 looks like an X, but there's no X over here, so can't pull that out. Definitely a Y. Okay, so yes to the Y, no to the X. I can have 4, and I can have Y. So this will be take away the 4 and the Y. I'm left with X squared. This will be 6. Take away one of the Y's, so I'm left with XY. Divide by 4, so this will be minus 9. Take away the Y, and I'm left with the Z. And just looking at that combination of letters, nothing in comment. Nope, so that's done. Okay, so this one is, let's see, not going to be able to pull anything out because that's 8 and that's odd. Yep, it's a trinomial. And this one is just going to be unpleasant. So 45 times 6, don't know. 45 times 6, 270. And this is one of those where if it does work, it's just going to take me a long time to find, because even though making this list is easy with a calculator, then it's just going to take some. So 1 times 270. Divide by 2. Nope. Divide by 2. 2 times 135. 3 times 90. 4 will not work. 5, yes. 5 times 54. 6. Yep. 7. No. 8. No. 9, obviously. 9 times 30. 10 times 27. 11, no. 12, maybe. Let's try. I don't think so. 22, no. 13, no. 14, no. 15. 16, 17, and have I missed one? 4, 5. Okay. Looks like if none of these I can get to combine together to make 8, Yeah, so if none of those work, then this just doesn't work. Okay, and done. That's the end. So hopefully you just got to look at the process. So it was a nice little bit of review. As always, if there's a topic that you don't see a video for and you want one, leave some note in the comments. We'll get to it as soon as we can. And good luck with your math homework.